Today is all about math. This video was inspired by a conversation that I had with my teaching partner. She was talking about how we should start adding more number lines into our math instruction, and so I wanted to look into some of the research behind math achievement and what strategies are useful and what maybe isn't so helpful. If you're looking for some really easy, low to no prep strategies to incorporate into your classroom for your students to build their math fluency, then stick around because this one has some good stuff coming your way. Well, hi, I'm Courtney. Welcome to my channel where we discuss educational research one study at a time so that you can incorporate it into your practice. This article is called Approximate Number Sense, Symbolic Number Processing, or Number Space Mappings, What Underlies Math Achievement, and it's published in the Journal of Experimental Child Psychology. This study looked at students between the ages of 6 and 8, so what they count as first, second, and third grade in Belgium. And this study started off with 91 students. It got whittled down to 71 students because some students had to be excluded for various reasons. I have a little bit of a problem, or a big problem, with the way that this study collected students that would be suitable because they were looking for typically performing students, and so they excluded students who were in lower income neighborhoods or students who were performing poorly. And again, if we want our research to be useful for students who aren't achieving well, then we need to start including students who aren't achieving well in our research, and then just divvy up your research findings into different groups so you can start making some comparisons. So I have said this before and I will continue to say it again, we have to stop excluding people from experiments and from research because they're not typical. We need research that supports students who are not typical so that we can help them become more advanced in their learning and in their abilities in school. Maybe if you're a quantitative researcher, you can help me make sense of this, but as a qualitative research, the whole we left people out because it didn't suit my results really is hard for me to grasp. Okay, let's get into what the study did to look at students' math performance, and then we'll talk about what the results were of each section. The first thing the researchers did was called a non-symbolic comparison task, and basically they had students look at images of two boxes filled with little boxes. It almost looks like what my desktop looks like on my computer. So a square or a rectangle with a bunch of other little squares in it of varying sizes. And students had to decide which box had more little boxes in it. Not which side had bigger boxes in it, but which side had more. There were 4 different combinations for students to look at, and then the researchers had students look at the same one 5 different times, and then the boxes would be on different sides of the screen as well. So it ended up being 140 images that students had to look through and decipher which had more. Now, I don't know if these researchers consulted an early years specialist, talked to a teacher, asked a parent, but to me, maybe it was a fast experiment and it was no big deal, but to me it seems like doing 140 of anything would be super boring and frustrating. So I wonder if that played into the results a little bit. I'm not sure. They didn't talk about that, and they didn't talk about why this was a developmentally appropriate task for children, but it seems like something I would not do in my classroom at least 140 times in one sitting. The next task was a symbolic comparison task. And so children were asked to look at a screen, and there would be 2 different numerals on it, and they had to pick the larger of the 2 numerals. Now there was no greater distance than 5 numbers between each numeral that was shown, so the distance can be too big. They wouldn't have 0 and a 9, but they might have a 5 and a 3. And so students had to discriminate which one was larger based on their understanding of what that symbol represents. So do they know that the image of a 5 represents 5, which is more than the image of the 2 being shown on the screen, which represents 1, 2. The authors made sure that the fonts were the same for everybody, the sizing was the same for everybody. Like, they were very meticulous about how this was portrayed, and they showed students 60 trials. Again, 60 seems like a lot to me, especially for a 6-year-old, but maybe students didn't get bored and they stuck through it the whole time. I don't know. These math articles that I read are so wildly different than anything else I read related to education, and I don't know. I don't know if this is just standard practice in how we learn about students' math, or if the math world could benefit from coming into the teaching world a little bit. I don't know what's going on here, and I would love to interview somebody who studies math understanding in children. So if you know any researchers who would love to have a chat with me, that would be a great way to spend an afternoon. The next task was a number line estimation task, and so children were given 2 different number lines. One had the numeral 0 on one end and 100 on the other. The other one had a circle with nothing in it and then a circle with 100 dots in it at the other end, so students could map out where a number would fit. After students were given the number lines, they were given instructions and some practice times about how to plot out numbers on a number line and how you would use this tool. Each number line was on a separate piece of paper, and so it wasn't like a whole list of number lines on one sheet of paper. It was just one number line on one sheet of paper, and there was instruction given to students. After they were given instruction and some time to practice, they completed the task on their own, and they had 10 different numbers that they had to plot on 10 different number lines. So that seems a little bit more reasonable. The whole go off and do independent work seems like maybe something you could do. I teach kindergarten, so there's a lot of me needing to float around the class during independent learning time. The next source of data that the researchers collected were from standardized tests. And so there were 2 standardized tests related to math and 1 related to spelling. And these were just done in the students' regular classrooms like they would be done any year. They were done a year after the experiments were done with the number lines and the looking at numerals. And the researchers just collected those from the teachers or from whoever handles the standardized tests and reviewed them. The spelling one was in there to see that students are typically performing, not that they're fantastic in math but not performing well in other subject areas. And so the spelling test was really just used as a control in this case. What the researchers were trying to do by looking at the standardized tests the year later is see if anything they did in the experiments could predict the results on the standardized tests. So that's why there's that gap of a year. And so the results were looking to see if a student did really well on the non-symbolic comparison task, did that predict their outcomes on their standardized tests? And so on and so forth with all of the different experiments that were done. All right, before I move on to the results, would you go ahead and give this video a thumbs up if you enjoy learning about research that can inform your practice and learning about strategies that are based on this research? And if you like more of this kind of content, would you go ahead and click the bell button and subscribe so that you can stay up to date on all my videos that talk about research in the classroom. The 2 math-related standardized tests involved a timed arithmetic test and then a curriculum test, so something that spanned the curriculum. And then again, spelling was used as a control. If we're looking at the timed arithmetic test, the only activity that was related to predicting good outcomes on the arithmetic test was the numeral comparison. So looking at 2 different numbers and quickly being able to decide which was greater and which was less than. In that initial experiment, the researchers were looking at the speed at which a student could figure out is 5 greater than 2 or 2 greater than 5. And so that speed helped determine the speed and accuracy at which students could complete arithmetic questions. And that makes sense because if you have a good knowledge of numbers and you can access that knowledge quickly, then you can put those numbers into application, like in answering arithmetic questions, quickly and accurately as well. When it came time to look at the curriculum test, the only experiments that showed to have anything to do with having a higher result were the number lines and again the symbolic comparison test. So the experiment where the researchers had students looking at squares and figuring out which side had more squares on it, that didn't predict math achievement on the arithmetic test or the curriculum-based test a year later. The symbolic number line did, and so did the number comparison. The number comparison task was the strongest predictor of math achievement a year later, and this was especially true for younger students. So the findings were a bit more watered down as students got older, but certainly in those younger years they were useful, and they were still useful as students got older, just not as useful. Now, it's important to know that the curriculum-based standardized test involved geometry, word problems, measurement, and still that early understanding of magnitude in being able to see the actual numeral representing a number and knowing which was larger out of the two numerals predicted future achievement even on those tests. And so those really basic skills going all the way back are super, super important for our students. The authors conclude by explaining how important it is for students who are struggling in math to go back to the beginning and really work on understanding what a number represents, where it's placed, looking at a number line, and where would 100 be compared to 37? Where would 37 be compared to 15? And understanding that there really is a linear progression there. And going back to those really basic skills can help students close some of those gaps that they're having later on in math. So those very basic skills are super, super important. It's very important to show students numbers and understand what underlies the symbol of the number, and that numbers exist in an order, and 100 will always be greater than 99. 99 will always be greater than 50, and showing them how that works. So here is what I love about these findings. As a teacher who does not like to spend hours planning lessons, building this into my instruction is super easy and low prep. I can think of 1,000 different ways that I could incorporate this into my practice. We already have a number line hanging in our class where you just have pieces of paper folded over with numbers, but I can take off some of those numbers and just give students 2 numbers and say, where would these go on the number line, and see if they can figure that out. I could write a bunch of numbers on Post-it notes and have students arrange them that way. I could have students match a number to a picture. I could have students just write down 2 different numbers. We did this in our class a few weeks ago, and I'm super glad I did it because now I have the research to back it up. But just write down 2 different numbers, put a circle around the bigger one. That way, in my class at least, they need practice printing, but they're getting their practice printing their numbers, and they're getting to see which number is bigger, which number is smaller, and being able to do it quickly. Super easy, super low prep. I'm thinking of ways that I can do this built into our routines. We wash our hands 18,000 times a day, and so while students are lining up washing their hands, we can do some of these activities. While students are getting their lunches, we can do some of these activities. Like, they could be good transitional activities. Student could work in partners, groups, whole class. So I am super duper excited about that. And we have Hundreds Day coming up in my class, so I cannot wait to add in some of this stuff to our 100s Day activities as well. Please tell me what you are up to in your classes. Have you done any of these activities? Is your mind brimming with ideas? Teachers are such creative people. I would love to hear how you can foresee using this research in your class, or if you're already using this kind of stuff and now you have the research to back it up, could you share your ideas with us, because we would love to see that as well. So please, like I said before, don't forget to like and subscribe so that you can get more of this type of content. And would you also share this video with a teacher friend of yours so that we can grow our community and share more research-based information for our students. As well, the more that this video gets shared around and liked and commented and all of that, the more YouTube realizes that there are a bunch of teachers who are looking for sound information about their practice on YouTube, and they will share this video with more people as we build the excitement up in our own community. Thank you so much for sticking around and watching this video. It's so great to have you here in our little teaching community. I hope you have a great day, and I'll see you later. Bye!